Is this thing live? Everybody hear me? I'm sorry. Thumbs up. All right. Well, good morning. Sorry it's so early. It's kind of brutal. You wake up. It's dark. It's rainy. It's not warm. This is Diagnosing Java Performance and Memory Issues in JavaScript-based Windows Store apps. My name is Andrew Hall. I'm a program manager on the Visual Studio Diagnostics team. It means we own the debugger, the profiler, and teletrace technologies that ship inside Visual Studio. So if you have any questions or problems with those, feel free to come talk to me afterwards. Immediately following the talk, I'll be at the Visual Studio booth right down the hall. So I'll be around for about an hour and 45 minutes afterwards, just hanging out there. With the way the lights are, I may have a little bit of a hard time seeing you if you raise your hand. So if you have a question, you may need to wave a little bit just so I can kind of notice it. They're shining right in my eyes. So why do we want to talk about performance? Right? In the new Windows App Store model and with other devices that also have app stores, customers have a lot of choices of things that they can go pull out of the App Store and use. And one of the first things you notice is if an app starts up really slow, or if it's really sluggish, if it's just sort of not a great, pleasant experience, people probably aren't going to come back to the application and use it again, right? They have, in general, usually a different option, and people don't want to use things that are painful, right? I don't know how many people here use Visual Studio 2010, but one of the biggest complaints we got was just how sluggish the UI was, and we got that 10 times more than any other type of complaint that we got. So if you want customers to come back and use your app, you need to make the performance of the application great. So we're going to talk about sort of 4 things. Briefly, I only have one slide and just sort of a couple reminders for good performance practices. Then we're going to get into talking about the tools. We're going to talk about 3 tools today. The JavaScript profiler that ships inside Visual Studio, the HTML5 performance analyzer that ships in the Windows 8 SDK, and the JavaScript memory profiler that has not actually publicly or officially shipped yet, but is coming out in the first quarterly release to Visual Studio. In mid-November will be the sort of RTM release of that. I don't know if anybody here has been using Visual Studio 2012 yet, but if you notice the little post that pops up in the bottom right corner of your system tray that says an update is available, starting with the second update that was available for that, the sort of beta bits, and as we've been kind of working on them for the JavaScript memory profiler, have been in there. So has anybody here used that yet? Played with that? One, couple. Good. So good performance practices. These are just a couple reminders for us to sort of talk about. I'm not going to preach long things on exactly how to make your app amazing, but be responsive. Don't block the UI thread. Users notice delays of more than about 100 milliseconds. So one of the things that we're going to talk about next is the JavaScript memory profiler. It'll tell you exactly how long your code takes to execute. So it's a good objective way to basically determine when you're doing things on the UI thread, how long is this taking to execute on average, right? And if it's going to take longer than that, break it up or use a web worker to do it in the background. Applications memory use is another thing that can really affect the performance of an application for a couple reasons. One, in the new world where users can swipe away from your application, the smaller your memory footprint, because your application is going to get suspended right after you swipe away. Smaller your memory footprint, the less likely the operating system is to kill your application and make it go away. It's going to keep it in memory until it needs those system resources. If it needs the system resources, it's going to start reclaiming the biggest applications first, because that's the biggest chunk of the pie. When the user either relaunches or swipes back to your application, if it has not been terminated, if it's still in a suspended state, right, it's going to load right back up. All your JavaScript's already been parsed, JITted, all the code's already in memory. If the application's been terminated, when the user wants to relaunch your application or swipe back to it, it's going to have to go reload the JavaScript files off disk. It's going to have to parse them. It's going to have to sort of build up your CSS again, apply all those styles, and so it's going to impact the startup performance. Also, JavaScript is a garbage collected runtime, right? And so if you start sort of having bad memory behavior in there, you can impact the application's performance due to garbage collector having to work really hard to sort of constantly work. In the managed code world of .NET, a lot of the performance problems that are found, that are ultimately memory, are found because of sort of poor performance due to the garbage collector chewing up a lot of the CPU cycles of the process. And then as you're developing, you want to tune your application's performance regularly, right? A lot of times you make a little code change here, there. You don't really think about testing performance till you're almost to the end. And a lot of times small decisions that you made maybe a couple months ago, a couple thousand, 10,000 lines of code ago, all of a sudden are really a problem. You didn't notice it, but you've built like a ton of functionality on top of sort of that incorrect design that you could have optimized if you'd caught it right away, but now it becomes a major refactoring effort in your code. So if you sort of, as you go, test it, make sure it's performing like you want, use the profiler we're going to talk about next to sort of objectively measure things. Subjective is obviously also a very valid thing when it comes to performance, although in this world, subjective kind of says, well, I have this computer, but somebody else might have a lower powered computer, especially with the ARM boards available. So, all right, so we're going to move into talking about the JavaScript profiler. I really want to spend the majority of my time in this talk actually looking at the tools that we're going to talk about. So this is just a little bit of background. It is an instrumentation-based profiler, which means it records exactly how long every function takes to execute, and it records exactly how many times it executes. So you get very exact data, very exact view of your world. The nice thing about that is that it's very objectively. If you're doing a bunch of work on your UI thread, things are slow, you can say, it on average is taking this long to execute, here's where I'm spending my time, things were called this many times, so you can use it to sort of reason about your code with a very exact view of the world. The downside, it only shows the JavaScript execution time, right? It doesn't show you work done by other systems. So you can do things in your JavaScript code that force, a new layout pass to occur, or you can update styles that then forces that part of the Internet Explorer sort of rendering engine to go do a bunch of work. We're not going to be able to show you what's going on in the other subsystems, so it's certainly not the end-all, be-all, but it's definitely a good tool. So 2 pieces of terminology before we delve into actually looking at the tool. And that's just the term inclusive time versus exclusive time. How many people here are familiar with those terms? Some people. So sometimes these sort of become a little tripping point when talking about the profiler because there's kind of things we put on the summary page or sort of front and center in a lot of the views. So inclusive time is the total amount of time from when your function was entered until your function exited. That's it. It doesn't matter how much time you spent in callees of your function, right? Inclusive time is just the total amount of time. The exclusive time is the amount of time you spent executing just the code in the function body. So basically, any function that you call, the time spent in there is subtracted out. So it does not include any time spent in your child function. So you can sort of reason about, because, for example, if you can have a top-level method that doesn't really do anything interesting, which can have, 90, 100%, depending on how your application is modeled, of your inclusive time during a trace, but it doesn't do anything interesting. So it kind of helps you reason about that. So here's just sort of a little illustration to kind of help make clear. I have 2 functions. I have function alpha. I have function beta. The little golden script thing is we're just going to say is the source code of the body. And then alpha calls beta. And beta doesn't call anybody. It just has source code in its body. So alpha takes 30 milliseconds to execute. It then calls beta. Beta then takes 50 milliseconds to execute. So the exclusive time of beta, 50 milliseconds. Pretty logical. In the inclusive time, anybody? 50, exactly. Right? So it didn't call anything. So in this case, they're the same. Now alpha, the exclusive time, is going to be 30 milliseconds. And what is the inclusive time of alpha going to be? 80. Yep, that's exactly correct, because it's the 30 milliseconds, sorry, that we spent in the function body, and plus the 50 milliseconds that we spent executing beta. So, all right, let's briefly delve into a demo. Let's go look at the tool. So Visual Studio, we're going to sort of follow my advice that I put up in the first slide, tune performance regularly. We're going to work on developing this app together. It's still at pretty early stages. So I'm just going to go ahead and launch it so you can see what it does. It's not particularly interesting at this point. Oh, whoops! I have it set to deploy on the Slate device that has fallen asleep. So that's where. There we go. So I'm just going to show you what the app does so far. So the idea is I kind of come to this world. I can pick a couple different pond images. I click one of these. It's going to navigate me to the pond. What I want to add next is the ability to click, have some water ripple over the pond, but I don't have that functionality in there yet. I can navigate back. I can go to a different pond. Right? Nothing super exciting, a pretty basic JavaScript navigation app. So we're going to stop debugging. Now, when it comes to image manipulation, that's not really my forte, but I have a person on my team who she's really good with this kind of stuff. So I sent her an email, basically said, hey, I hear you have some code that might do this for me. She said, sure. She attached the source code, which I've already downloaded. And then she just gave me a little snippet to add to my initialization logic. So I'm going to go back here, and I'm going to close my output window. So on my pond page, I'm going to add the source file that I downloaded from her. Can people in the back see that? Is that font size large enough? I saw a thumbs up in the back of the room, so I'm going to assume that's yes. So I'm going to go ahead to my downloads. I'm going to pick my pool.js as a file that she gave me. I'm sure I'm unique. I'm sure nobody here has ever taken source code that they found from anybody else and copied and pasted it into their own functionality. So this is the initialization code she gave me. I've just pasted it here because the browser adds some unnecessary formatting. So I'm in my init function. When I load the page, perfect. I'm going to save it. It would help if I had pasted it not over part of my existing stuff. There we go. And so I'm going to go ahead and launch without debugging now. I want to see how it works. One of the things she told me in the email that she sent me is that she had not actually really tested this with large images. She'd only played around with this on small canvases. Notice I launched without debugging. In the JavaScript world especially, although it's true in any kind of performance profiling, you never want to evaluate the performance of an application when debugging. And that's especially because in JavaScript, does anybody know the difference between when I'm debugging versus not debugging? Right, so in Internet Explorer, when I'm debugging, I'm interpreting all of my source code. So it means it's constantly just interpreting the JavaScript code. When I don't have a debugger attached, it jits the code, and so I'm now actually executing jitted code, which can be about a 10x performance difference for really intensive operations. Let's go ahead and click. Let's see how this performs. Anybody see that there's kind of some ripples up in the top part? And you know what? That's not really the performance I'm looking for, right? And this is a pretty decent laptop. So what's going to happen if I move this over to my Slate device over here? So let's go ahead and navigate back. Oh, and the other thing I noticed is when I navigated back, it seems that it kind of slowed down my navigation back performance. Like it was really snappy, and now it's not really snappy. So, let me do this. Get rid of that way. So we're going to go ahead and use the Visual Studio Profiler now to sort of go profile these two issues that we found. Right? So the first thing I want to do is I'm going to go to the debug menu. I can launch the tool from the debug. There's two options: start performance analysis. This just launches profiling if we want to profile like the startup of our application. And then we also have an option that I'm going to use here. It's start performance analysis pause. And what this is going to do is it's going to start the profile, it's going to set it up, but it's not going to be collecting data. So I can get to the scenario that I want to profile. I can come back to the IDE. I can say start, and now that's when I start collecting data. Let's go ahead and start performance analysis pause, because I don't need I'm pretty happy with the startup performance of my application. So it's going to go ahead and launch. While it's launching, the profiler does slow down the launch of your application, and it will impact the performance. So you don't want to evaluate performance of your application while you're profiling, but it is a good tool to accurately measure. And the reason for that is what it's doing is every time, when it starts up, it's asking the JavaScript engine to instrument the function enters and exits for us. So that's why it slows down the startup, because it sort of affects the JIT performance time, because it has to do extra work. And then while I'm running the application, every time I enter a function, I have to log that event, or exit a function, I have to log that event. So that's going to also obviously impact the performance of my application. How much it impacts the performance of my application is directly related to how many function calls I'm doing. So if I'm doing a bunch of stuff in like a for loop, not calling a lot of functions, you're not going to see a big difference. If you're doing something like recursively, where you're doing almost very little work in the function body and it's a lot of function calls, then it's going to much more significantly impact. So let's go over here. I'm going to navigate to my application. Go back to Visual Studio. I'm going to say resume profiling. So I want to come back. I want to click. I want to let some ripples start to occur. Let's go ahead. There's probably enough data here, and I'm going to go ahead and click Stop Profiling. So what it's going to do is it's going to go sort of stop, finish the data collection, and build an analyze report for me. Depending on how much data I've collected is going to depend on how fast this happens or doesn't happen. I don't know how many people are familiar with some sampling-based tools. So for example, Chrome has a sampling-based profiler. That's very sort of predictable in terms of how big of a log file you're going to get, and so how long analysis is going to take, because worst case scenario, if you were using the CPU every time it took a sample, you're going to get that many samples times the number of milliseconds that you're running. So you ran for 20 seconds, 20,000 samples is the worst case scenario. Instrumentation, because it's directly correlated to how many function calls you do, I could run for 20 seconds and get a couple million or billion function calls, or I could run for 3 hours and have none if sort of the app is sitting there being idle. So first thing I'm going to do is I'm going to, in the IDE, it's a little trick. We have a shortcut to do it on the summary page, but we have this view called full screen. It keeps all your document views, but it sort of makes all the tool windows and stuff disappear. So I think it's actually kind of nice if you're sort of working and have the documents that you want up, or you're working in a report like this, so that we have a shortcut right here. So the first thing you're going to see is we have a summary page that comes up, and this is going to give me some summary data about the profiling trace that I just took. So the top number, this 7.4 seconds of total execution time, is the amount of time that JavaScript was executing during the time that I spent my trace. It's not actually how long my trace was, it was just how much time you spent executing JavaScript code. Although in this particular case, we were pretty much executing code most of the time, so it's pretty reflective of how long we actually, collected for. So then I'm going to have my hot path. This is, while it was crunching and doing that analysis, it analyzes the call stack that the most inclusive time was in. And then below, we have the functions with doing the most individual work, and this is exclusive time. Right? So we talked about inclusive versus exclusive. And so very quickly, just from the summary page, I should be able to get a good idea in my scenario of what my code was doing the most frequently. So we have a couple of views available. I could go, for example, to the call tree view. I click this little icon up here, and it'll expand the hot path. And so I can see this matches exactly what I saw on my summary page. Ripple, which is the function that I got from my team member who sent me the code, is then calling math.floor. Does anybody notice how big this number right here is for math.floor? I'm spending almost 42% of my time executing math.floor, and I called it 20,902,000 times. So that's a lot, right? Like the average elapsed time is 0. Like it executes so fast that the math rounding is, but I think I can make this faster, right? Because I know math.floor is inherently slow because it does a bunch of security checks. So, because I'm not a super smart JavaScript programmer, but I did some research. And it turns out there's a little trick that I can do to improve the performance. Instead of using math.floor, if I know that I'm operating on numbers, I can go over here to my pond.pool.js is the one that she gave me. So let's open that up. So I'll actually go back here and show this really quick. Full screen. And that is, I can say, okay, take me to the function details view. I right-clicked on it. And what this is going to do is this is going to jump me to a butterfly view of the world. Shows me my source code, right? So it and then it shows me the functions that are calling me. Now in this particular case, Ripple was the top of the stack. Nobody called. And it calls floor, performance data. So I can scale this down a little bit. The font size sort of is producing some issues here for the purpose of the presentation. But now if I click this, it's going to open my file. So I'm going to go ahead and replace the file, and I'll show you what I did in a second with the one that I just did. And so math.floor is my issue. So let's look for math.floor. And in all the cases, instead of using math.floor, I just do a bit shift of 0 bits, which is sort of a trick that the JavaScript engine has now basically turned it into an integer, has dropped the floating point values, but bit manipulation is a lot faster than calling a function in the runtime that does some security checks on the number to make sure that it doesn't do bad things if you, for example, pass it a string and you want the floor of it or something like that. So I can click. Yep. So I found all of my
all my map.floors. I replaced it with bit shift. Let's go ahead to debug. Let's see how if we improved it or not. Start without debugging. Click. And my frame rate's a lot better. So pretty quickly, I used the profiler for a few minutes, and I was able to improve the performance of my application in that way. So what about the second problem that we talked about? We said, okay, well, the navigation back seemed to be a little bit slow. So let's go profile that one. So I'm going to launch performance analysis pause, because the scenario that I'm interested in here is sort of the navigation back. It's going to start up. Any questions while it's starting up so far? No question. Okay. Thank you. All right, so I've navigated to my page. I'm going to go ahead back. I'm not going to do anything interesting on the page. I'm just going to resume profiling. I'm going to go back to my application. I'm going to navigate back. I'm going to come up. I'm going to stop profiling. Let's see. From my perspective, the only thing I did was a navigation, right? So, So it tells me that Ripple is 98% of my inclusive time. Sorry, toggle full screen. Let me show that. So let's go ahead to the call tree view and expand the hot path. And I'm going to see that Ripple, which is this function that I picked up from her, has been executed 56 times. So now I can start reasoning about the code based on the function call count. And sort of another way to do this, I want to show another view while we're here. I can sort by any column, obviously, is this modules view of the world. In the JavaScript world, it treats every source file as a module. So if you're sort of interested, not that I need it in this particular case, but it's another view available to you, I can expand and I can see the functions. And I can say, well, this Ripple code is getting called 56 times. Something's executing when I'm trying to navigate back, but I only want rippling if I've clicked on the canvas to actually start a ripple. So let's go ahead and fix that problem while we're there. So I want to go back to sort of navigate here. And so what I'm going to do for this one is, I'll show you what I did in a second, but I'm going to add a, basically what I want to do is, I have added a callback registration when I actually call a request animation frame after I do the ripple. And I'll show you, and so then I assign it here. So callback equals window. And then what I do is when you click drop, so what I want is only when I actually have my mouse event handler and I click drop to start the animation, do I want to start it. And the reason I've done it this way is so if I click multiple times, because I can ripple multiple places, I don't want to start multiple sort of competing request animation frames. So I want to make sure that it only happens once. And then I'm going to go back to my pond.js, and I notice that in my initialization code, right, in init, is actually calling water.ripple. So we're going to go ahead and get rid of that. Just go ahead and comment it out. So now, in theory, I shouldn't actually be executing any code unless I'm doing something. So click on the canvas to start my rippling animation. So let's go test that one more time. Start without debugging. And perfect. It's a lot snappier now. So I've sort of used a couple different views in the profiler to reason about my code in that way. So any questions so far? Yes, sir.
Is this tool only available for JavaScript debugging and profiling, or I can actually profile standard C# code?
Okay, so the question was, is this tool only available for JavaScript, or is this available for C# and native code as well? This particular instrumentation profiler, fortunately the answer is kind of. In terms of Windows Store applications, we have CPU sampling for C# and C++ code, but we don't have an instrumentation profiler for Windows Store apps for those types of code. However, for sort of classic desktop applications in the Visual Studio Professional SKU, there is instrumentation profiling as well as CPU sampling available for classic desktop apps. So, yes, question here.
A lot of this looks very to the F12 tools in IE. I mean, does this offer any advantages over using the tools that are just built into Developer?
Okay, so the question was, this looks very similar to the tools, the F12 tools that are built into Internet Explorer. Is there any advantage that this offers over that? The answer is actually you're getting the same data, so you're correct that it's effectively the same thing. The difference is the F12 browser tools don't work against Windows Store applications, and this doesn't target the browser. So from that perspective, the advantage is it depends on what your target is. If you're building a Windows Store application, you need to use the one built into Visual Studio. But the reason it looks very similar is that it's actually the same data. It all comes from the script profiling APIs that are built into the JavaScript runtime in Internet Explorer. Okay, so the next tool that I want to talk about is called the Performance Analyzer for HTML5 apps. This ships in the Windows 8 SDK. Has anybody used this tool or does even know that it exists?
Is that the thing where it walks you through, like close it and snap it and come back in a minute?
Yeah, so the question was, is that the thing that walks you through, close it, snap it, come back in a minute? The answer is yes, that's exactly what it is.
It was excruciating.
It was excruciating. That's the comment. Well, let's take a look at it. I want to show you the tools that are available. It does some useful things, I think you'll see, but so it's just a matter of opinion. But it's actually developed by the WWA host team, the guys that actually do the Internet Explorer JavaScript runtime stuff for Windows Store apps. So what it does is it walks you through testing your application. That was his comment, is that thing that says step 1, do this, step 2, do this, step 3, do this. It generates a report measuring sort of 13 different tenets of performance that the WWA host, the runtime guys, have defined for basically working with people inside Microsoft that were building JavaScript Windows Store apps. Sort of identified these as kind of the major pain points. And so it walks you through it. It says step 1, do this, step 2, do this, step 3, do this. And then it's going to give you a report that's kind of, on these different things. I don't think you need me to read the list, but some of the interesting things that I think are really hard to catch with potentially other things are sort of the image scaling, the UI responsiveness. It'll tell you if you've hung the UI thread for too long. It'll evaluate your memory footprint, right? It'll sort of try to detect if you're leaking memory based on the memory trend of your application. It'll sort of evaluate how much you're using, things like that you could sort of maybe go figure some of them out based on looking at Task Manager and stuff, but it wraps it all up in kind of a nice single report for you. So that's kind of it. I'm going to briefly demo that. We can decide how. So where this tool is, and it's not very discoverable, is it ships in your the SDK. So it's under your Program Files directory, Windows Kits, 8.0, and this is where it gets kind of hard. I knew that these guys had developed this tool. I knew that it installed with my Visual Studio because Visual Studio installs the Windows 8 SDK on Windows 8. And I still couldn't find it. I had to send them an email and say, hey guys, where is this tool? So after you get into your Windows Kits 8 directory, it's in the bin. Pick the architecture that matches the architecture of your operating system. It doesn't matter what architecture your application is. And then the app perf analyzer is where it is. So I'm going to go ahead and launch this tool. It's app_perfanalyzer.js.exe. Set the elevation prompt. Select the app to analyze. It's going to say my pond. That's what we're working on. Let's get started. I'm done. Take me to the next step. This step, it just wants me to launch the app and use it. It's not collecting any data yet. The reason it wants you to do that is it wants to make sure sort of all the runtime DLLs and everything are loaded into memory, so you're not evaluating the performance of sort of an exceptional case, like it's the first app that you've launched on the system, everything's cold. We've been using the application, so we know that it's all up in memory, so I don't have to do that. So I'm going to say I'm done. I'm taking me to the next step. It wants me to launch the app, wait 60 seconds, return here, because it just wants to evaluate the startup performance of my app. I'm going to briefly launch the app, but I'm not going to wait 60 seconds because you guys don't need me to. This is not interesting. Startup performance is not something that I'm interested. It does want to make sure that it gets suspended correctly, so we will wait just for to make sure that it gets suspended, although I don't have to wait based on time. I can wait till this goes to a suspended state. Perfect. I'm done. So what we were just evaluating there was the startup performance. For the purposes of our talk, it evaluates it, but that's not anything we're sort of interested in the report. Now it wants me to evaluate the snap performance of my application. So it wants me to switch back to it. It wants me to snap it, which because we're sort of in early development here, I haven't actually done any snap functionality. It doesn't do anything interesting. It basically says, come back, wait 60 seconds, unsnap, return here, wait till it gets suspended. I don't need to wait 60 seconds because I don't do anything interesting in my snap. Let's wait till it gets suspended, however. Suspended. I'm done. And this is the one we're actually interested in right now. It's going to be the typical use case scenario. It's basically going to say, use your app, it's warm, you've started it up, we're going to now evaluate. This is a scenario-based profiling. So I'm going to go back to my app, we're going to use it, we're going to navigate. Let's go ahead and click here. Let's do some ripples on the pond. It's pretty good. It does, in general, it wants you to use it for at least 60 seconds. I'm not going to use it for a full 60 seconds. But so to the gentleman's comment about sort of the walkthrough can be a little bit painful and tedious, you can sort of choose to just gloss over the steps if you're just interested in some of the scenarios along the way. So.
Well, it's good to know what it is it's trying to get you to do in each of those things. That's very helpful. The other problem I have is that you switch to your app and instructions would go away.
Yeah. So the comment was, it's helpful to know what the different scenarios it's interested in are. So you can sort of choose which one you want to evaluate at any given point. In the report, you'll see it'll actually tell me. So it's going to yell at me in the report that basically the first two scenarios I didn't collect data for long enough. But then he said the other pain point is the fact that when you switch to your app, it goes away. Yes, that's sort of a problem unless you have multi-monitor, and then you can put it up on one and have the other. So that's a very valid point. So we've been sort of running the app for a little bit. We've been collecting data. I've used it, navigated around. It tells me how long I've been running. It wanted me to do it for at least 60 seconds. So I've been running for 85 seconds down there. Let's wait till it gets suspended again. And so the reason it wants you to wait till you get suspended in all of these cases is one of the things it evaluates, as I talked about sort of on the first slide of performance guidance, is it wants to evaluate what your memory footprint is. If your memory footprint doesn't go down, you'll see in the report that it's going to generate for me that it's going to give me guidance saying, hey, you're not releasing any resources when you're getting the suspend event. You should think about releasing resources when you get the suspend event. So any questions while it's generating my report for me? No questions, all right.
What kind of resources would you let go of?
Okay, so the question was, what kind of resources would you let go of? It depends on what your application's doing. You could think about, for example, in the particular scenario that I have there. So I have an image on a canvas, and there's 2 byte arrays of the different buffers that are sort of how it does the image manipulation. It sort of does the rotating buffers. So I could think about on the suspend event, maybe releasing the image or cleaning up I don't need to hold basically 2 copies of the image in buffers. If the image is pretty big, like multiple megabytes, so I basically every copy of the buffer, so I could zero out those buffers and then just rebuild the buffers, for example, when I reopen the application. If you have sort of some file resources or things like that are sort of all about displaying UI to the user, you could think about sort of freeing those up while your application was getting suspended, because if it's just things that the user's looking at, sort of the interesting thing about the startup performance is, as I said, one of the real advantages of not getting terminated is all of your JavaScript is up, JITted, the files have been loaded off the disk. So it's going to have to redraw the stuff anyway when they come back up, so it's probably not going to be a big deal if I have to, for example, rebuild my image buffers. Sorry, I collected a lot of data in this scenario. I got distracted by questions, so now it's working on a really big data file. Question back there.
Does the tool actually come with the standard installation of VS.12, or is there an SDK that we need to install?
So the question was, does this tool come with the standard installation of Visual Studio 2012, or do we need to install something special? If you install Visual Studio 2012, it doesn't matter the SKU. I'm actually using the Express SKU for Windows 8 here on this machine. It installs the Windows 8 SDK, and this tool is already on the box. And then the other thing to notice, and you see what it's doing here, is this is what I wanted. It's generating it generated the report for the app launch for the snap, and now it's doing the typical usage scenario. And then sort of the other thing that might be interesting to call out, because I got this question previously, is in the bin directory, you have all 3 architectures, ARM, x64, and x86. There is not a remote integration experience for this like there is for sort of the Visual Studio tools, so the profiler, the debugger, the JavaScript memory tool that we're going to look at next. But if you want to run this on an ARM device, for example, you can copy this off from the ARM directory in your folder here, and then you could run it, put it over there via USB thumb drive. So, all right, so it has opened my report for me in Internet Explorer, and it's going to tell me that, So I passed 17 scenarios. Can people in the back see that? Is that big enough font size? Do I need to make it a little bigger? I'll make it a little bigger. Zoom, let's do 150%. So I passed 17, I have 7 warnings, and I failed 5 scenarios. So let's look at the failed scenarios first. Those are probably the most interesting things. So it's going to tell me that I didn't run it on the correct hardware. If I use that guidance, it'll basically yell at me that I was using an x64 machine. I wasn't evaluating the performance on like an ARM device like I have right here, because you didn't really want to watch me try to do this on an ARM device today. But so it's something to just keep in mind that my performance data is only indicative of the machine that I'm running on. You should always test to the lowest common denominator. Image scaling. That's interesting. So it's going to tell me that I scaled image. It's going to say the original size of the image. I scaled 3 images. And the report, it would tell me that this was actually in my sort of startup scenario, the app launch scenario. So I can collapse. I can go to the different sections, the scenarios here. But when I start the application, even though I'm pretty happy with my startup time, it tells me I'm scaling 3 images. It tells me the name of the image, right? Pebbles.jpg, tropicalreef.jpg, and koipond.jpg. It says the original size of the image was, 1280 by 800 in this particular case. And it was actually rendered to 150 pixels. So that CPU has to do some work to scale an image. So that's something to keep in mind. So I'll kind of put that in the back of my mind. Image scaling again. So this is going to be just if you sort of look at the way the report's organized for the sort of typical use case of the app, that would have been whenever I navigated back to the page. So I'm not caching any of that in memory. Basically, every time I navigate back, it's scaling. And then the memory footprint. So let's go ahead and take a look at the memory footprint. And it says, apps run better when they use smaller amounts of memory. We talked about this. An app should have a memory footprint of less than 60 megabytes. This is guidance that they've done based on research. The operating system is not going to enforce or punish you or terminate you if you go over that, but it's just sort of good guidance that they say you should shoot for. And it says my pond reference set is 118 megabytes, and the working set is 142 megabytes. This exceeds the 80 megabyte reference set maximum and 80 megabyte working set maximum failure threshold that they've defined. So it's telling me that my memory is something I should go look at, which works out well because the next tool we're going to talk about is the JavaScript memory profiler that we put in the IDE. So it's a snapshot-based tool. The goal is to help you identify unintentionally retained memory. So memory leaks in the managed world, right? It's not in a garbage collected runtime. A leak basically means that you accidentally held a reference to something when you didn't mean to, so it can't get picked up. Unlike native, where it means you lost your reference before actually freeing it. It's a snapshot-based tool. It means as you're using your app, you're going to click Take Snapshot. When you click Take Snapshot, it's going to sort of suspend the application. It's going to go walk the heap. It's going to dump all the information about the object types and the reference graph for those objects. And now you have a snapshot that represents one instant in time. It's not sort of continually collecting data over time while you're profiling like the performance profiler was. I can take multiple snapshots at any given point in time that I want, but each snapshot represents one instance in time. So I can't sort of track the lifetime of objects with like a nice automated way with the tool, but I can see. And it shows JavaScript and DOM elements. So the numbers that we'll see when we look at the tool here in a second represent the size of the JavaScript object plus the size of the objects that are contained in the DOM, which includes things like images, divs, or what you think of as sort of HTML tags and stuff that's just displayed to the user. And you can also see the reference graph. So once you say, oh, I don't get why that's there, like I would expect that to be gone, that's holding on to a lot of memory, why is it not getting garbage collected? We'll show you the reference graph that'll show you what's preventing the garbage collector from actually collecting it. So 2 pieces of terminology to just really go over really quick. Size, pretty intuitive. How big is the object in memory? And then retained size, and this is the one that can sometimes provide a little bit of confusion. I have an illustration of this on the next slide. But it's the amount of memory that the object is preventing the garbage collector from reclaiming. It seems pretty simple, but this is sort of the confusing part comes in. So size of the object plus the size of all referenced objects, any objects they reference, that the current object is the only parent of in the memory graph. So what that means is if somebody else has a reference to an object and you get garbage collected, it's not going to, so it's not part of your retained size. And so I have this sort of really simple reference graph right here. a memory graph, I have 4 objects, right? A, B, C, and D. A and C are root level. A has a reference to B, and then A and C both have a reference to D. So the sizes, pretty intuitive, right? Just the size of the objects. Anybody tell me what the retained size of A is going to be based on the explanation I just gave? I heard 6. 7. I heard 6 and I heard a 7. The 6 is the right answer. And the reason that the 6 is the right answer is because A, if it gets collected, obviously its size goes away. And B, its size is going to go away. But even though it references D, C also references D. So D is not going to be able to be garbage collected if only A disappears. So the retained size of everybody else is actually just matches their size because sort of nobody else has a one child in a true parent-child relationship. So, all right, let's go take a look at the tool. Let's go back here. All right, so the first thing I want to just do is just to show that this stuff all works just as well in your Slate device using the remote tools if you've done remote debugging. So first thing I'm going to do is switch this to be a remote machine. And then I'm going to say just debug, JavaScript memory analysis, and I'm going to launch my startup project. So it's going to go. It's going to tell me that I have an elevation prompt on my remote machine. So I'm going to switch over to show you what that is. It's switching right now. So I see I have an elevation prompt over here. I'm going to accept it. I can use my application. Sorry, it's not super clear. But all I really actually want to do is show you that that worked. So now I'm back here on my regular device. Oops, sorry, wrong one. So I can take snapshot. Perfect, I have a snapshot. So let's stop and actually take a look at this. So it's live. I can continue using the application. So for example, one other thing I'll show you how to do, but we have this concept of user mark. You can write stuff. So if I navigate over on my app, I just switched to a different thing. You can see this little glyph popped up. It tells me that I navigated to Koi Pond. I'll show you how to do that in a second. It's just a console.writeMark, and you can pass any string you want. It'll show up there. And so it's a way to sort of instrument your code so you can track like direct correlation between seeing memory changes. And indeed, in this case, you can see that my memory went up after that. But the first thing I'm interested in, it told me I need to keep my memory under 60 megabytes. That was sort of the recommendation of the tool. Well, I see that I'm already at 11.48, so we'll just call it 11.5 megabytes. For my little start page, this is a screenshot of what my start page was down there that has 3 little tiny images and really not anything else interesting going on. So if I really want to try to keep myself under 60 megabytes, I probably shouldn't be using that much memory for like a tiny little start page. So let's go in and see what, so this is the Dominator's view. If anybody's familiar with other memory tools, a lot of times what they do, Dominator's view picks the largest instances of objects and aggregates it. You have another view up here that's types that'll then sort of aggregate by type, and if you want to see individual instances, you know, for example, of string, you can expand that and, you know, deal with all the number of strings. Let me go actually do this to make life easier, full screen. So let's go ahead back to the Dominator's view. Let's see what's big in here. Global, okay, that makes sense. It holds on to everything, so it's sorted by retained size right now. That's probably not interesting. Going to image. Well, I see 3 images kind of high up here in the Dominator view. That's what element is, and the elements are actually just holding on to the images. So that's a lot of megabytes right there just in images for considering if we think about what my screenshot looks like back here that I have 3 tiny images. And now I remember that when I ran my HTML5 app analyzer, it actually told me I was doing image scaling. Like I'm loading really big images. So the question is, can we get a memory win right away if I just load thumbnails instead of actually loading the full image and scaling it? Perf win and memory win. So I'm going to go ahead and stop this tool. I'm going to now go back. And I've done a little memory snippet here. So in my initialization code, what I want to do is instead of just setting the source for the image, let me go back to home. And it's here. So you can see, I'll show you in 1 second because So instead of before, what I was doing is I was just setting the image source equals the URL to that. Now what I'm doing is I'm going to actually use the new WinRT APIs to get the thumbnail of an object, and then I'm going to set the image source to be the thumbnail of that. So let's go ahead and rerun our scenario. I'm going to switch back to the local machine here because it doesn't make a particular difference in this case. So I don't have to switch back and forth, and you can see what I'm doing. And JavaScript memory analysis. Let's go ahead and launch startup project. You only have to accept once per Visual Studio session. The reason I had to accept twice is I had to accept once on different devices, obviously, for elevation. So let's go back. Let's take a snapshot. Perfect. I'm now down to 1.57 megabytes of heap. So I just got almost a 10 megabyte win right there. By really quickly, I was able to see some inefficient use of memory. So now the second thing that I remember is that when I navigated, it actually really jumped my memory up. And sure enough, my memory jumps up when I navigate. That's fine. It makes sense. But so now the question is, if I navigate back, does my memory go down? Am I leaking this stuff, or is this sort of a memory neutral operation? I'm going to navigate back. All right. Now, the one nice thing is when you click Take Heap Snapshot, it is going to force a garbage collection to occur. So even though you can't guarantee on the graph that your sort of memory will update instantly, right, the garbage collection may take a little while before it kicks in, when you click the Take Snapshot button, if it's going to be able to GC stuff, you're going to see your memory come back down, and the snapshot's going to only get the stuff that's really actually in memory. So that's going to force a garbage collection to occur. And I can see that I've increased by a little bit came back down, so some stuff got GC'd. But not everything got GC'd because I'm up 4 megabytes. Okay, so, well, is that sort of a one-time thing? Did some stuff get cached and initialized, or is it actually a problem? So let's go back to another one. Let's navigate back. And my memory went back up. And I can see that it got a little smaller that time, but it's not sort of back down to memory neutral. So I want to diff the first and the second one. So all I do is click on this, on the red thing here. It's going to, and it's going to automatically jump me into a diff view of the two objects. We're going to see what's still alive in memory. So, I know. Okay, everything looks good. Sorry, I actually messed it up. Let's go back here. Let's do this. Now let's actually exercise our app a little bit. Okay, it went up. Let's take another snapshot. And this time, notice it didn't come back down. So the first time I was doing some caching stuff, but this time, after I sort of used my app, so something I did there is actually not letting my, it's now actually, I've really actually introduced a leak by exercising the functionality of my application. Because you can notice it went up 12 megabytes. Let's just double check that. Jumped up again. And actually went up 15 meg. And this is the diff from the previous snapshot. It's not the diff sort of overall, because you can see this was 17 megabytes in my previous, and now I'm up to 33. So that doesn't look good. So let's go ahead and see what's changed. And I can see that right here at the top of my dominators, I have ripple, which is that function that I introduced. And so it is being held alive. Here's the reference graph. There's 3 things that, according to this, have a reference to it. And the first thing I notice is that a callback has a reference to it. That makes sense. Now, if I think about, as we've been developing the application, we've been using an MS request animation frame. So, right when I click the canvas, like, there's a function handler that requests, and I said, you know what, I never canceled that when I navigated away from the page, right? So let's go ahead back. Let's try to make that change. Let's make sure that we can, I'm going to go ahead and stop this. And let's cancel the MS request animation frame when I navigate away from the page. Maybe that'll fix our memory issue. So come back here. And what I'm going to do is I'm going to introduce a cancel function into my pool.js. So, okay. And then in my pond, in my navigation away event, I want to cancel. Oh, okay, but you know what? The variable is actually getting declared down here. So I need to now move it up here so I can call cancel in the navigation handler. Here's my unload. Let's call water.cancel. Oh, and the one thing I promised to show, so I'll do that real quick, is the console.write mark. So I've actually just added it to my default JS because this is a function that gets created at only when you're memory profiling. So I registered my own class called Diagnostics, and it's just profile mark. And so then you check that the function exists, and then you just call console profile mark, and then pass it whatever string you want. But if you just try to call console.profileMark, unless you're JavaScript memory profiling, it'll actually crash, tell you that the function doesn't exist. So, okay, so I'm calling water.cancel here in my pond.js, so that's going to get rid of my callback. So in theory, this should fix our memory leak for us. Launch startup project. Let's go take a snapshot just so we have a baseline. Boom. Run this, let's navigate away. Take snapshot. Didn't fix the memory leak. So question is, what's changed? Well, there were 3 things in the reference graph before. Maybe I didn't get all of them. Let's go to the Dominator's view. Looks a little different, but I noticed that I still see pool in here, which is still retaining a lot of memory for me. So cancel. Okay. Well, cancel's keeping it alive. That's a function. Drop. No. What's really holding on to this? All right. So I did not design the demo. I'll be very honest. I wanted to be honest about the data. Right. This is the real reference graph, and life can be kind of weird in the reference graph world. Sometimes you have to dig around because this is actually how the runtime sees it. Well, what's holding water alive? Water is my function that I just did, or my variable that I just added. Oh, okay. So init this is basically describing the anonymous function that is enclosing water. If I start drilling these up, it's the update layout. It's the anonymous function. So this is the representation of this. Pond.js of these variables right here. And so what I realized is that by adding water to the parent scope, when I tried to fix the original memory leak, I've now changed the scope of it, and so it's not being able to be garbage collected. It's because being held on to by an anonymous function that exists in memory. So let's null water out after we go ahead and cancel the navigation. Debug. Oh, I'm still going. So to stop before I can relaunch. Go back here. Snapshot. Boom, 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 boom. I can see that it's not holding on as much, right? I was leaking 15 megabytes before. I'm now leaking 3 megabytes. So now I could go in and figure out what I'm leaking. I'll actually just tell you for the purposes of time. There's actually another image that's being leaked because I left the image load initialization handler attached to it. So, but we only have 7 minutes left. So, summary, install the quarterly update. You're going to get the memory tool that I just showed you. You don't have to sort of do any extra work. Visual Studio will tell you with a little pop-up notification that updates are available when you launch it. Just install that. You have the JavaScript memory profile we showed. Use the tools you have available to improve the performance of your app. All of them are free. All of them come with Visual Studio 2012 for Windows 8, the free version. 2 of them are part of the IDE and sort of work in the remote scenario. And then you also have the HTML5 performance analyzer that we briefly looked at. If you want to sort of use that tool just to focus on specific scenarios and gloss over all of them so you don't have to use all of them, you can make life a little bit easier. And that one does have one that you can put on a USB key and run on an ARM device if you need to. So, questions? No questions. All right. So there was 2 related sessions. I believe actually both of these are already done now, but you can go grab them on the Channel 9. All the sessions will be posted, and you can download the slides. So we have building high-performance JavaScript for modern engines and modern JavaScript. These are both given by the JavaScript engine team. And then after the talk, if you want to go download the slides once they're posted, I have links to the documentation for all of the stuff that I showed and some performance guidance. These are 2 talks that were given at Channel 9 one of them is a talk and one of them is the corresponding documentation for sort of good performance practices for JavaScript. And please submit session evaluations either using your Windows 8 Build app or you can do it online. So, thank you.